Hi everyone, I'm Arun Malve and welcome back to Good Shows. If you're enjoying this video so far and maybe even learning something new, take a quick second to like, share and subscribe to my channel. And hey, don't forget to smash the notification bell icon. Welcome back to the part 2 of Proxmox Kubernetes lab series. In the previous video, we have set up one master node, two worker nodes, all running under Proxmox with IP address, QEMU guest agent, and SSH access. In this video, we're going to cover container runtime, installation and setup, configuring Kubernetes worker nodes, and user management of cluster access, adding the worker nodes to the cluster, deploying the first container, exposing it to the NodePort. And this will be end-to-end testing as well. Let's get started. So sudo apt container install containerd is the command. So why are we installing this is Kubernetes needs a container runtime to actually run pods. Without this, you just have empty promises. So once it's done, we need to do that activity on the worker node 1, that's S1, and hit Y to yes, and that's the installation done. And let's move on to the master node and type in the systemctl status containerd to check if the containerd is running actually. Yes, it says active and running. And we are good to move forward with creating the config directory with sudo space mkdir space /etcd /containerd. Why are we doing this? By default, containerd doesn't create its own config directory, so we do it ourselves. It keeps configurations, rules, and behavior with life, like its user manual, instruction manual. Let's go ahead and run this command to list it and check to verify the directory created. Okay, looks like the directory is not created. I think I need to rerun the sudo mkdir. Okay, let me try the containerd config default. Okay. So what is this command does is containerd space config space default space pipe symbol sudo t /etcd container d /config.2ml. Why is scary looking command? Yeah, so the reason for it is like it generates the default configuration file. Otherwise, containers runs with hidden defaults you can't see or edit it. We'll need to tweak one of the critical settings later in the systemd C group. Without this, Kubernetes throw tantrums. So once it's done, let me list it. Okay, there you see. So the next step is we need to do some magic in the systemd code. So Kubernetes like to manage C groups with systemd, so we need to edit the config file. So run this command with sudo space vim space /etcd /containerd /config.um. Find the systemd C group, which is under right. Just type in /runc.options under the containerd runtime, and you should be able to see the plugins for the systemd C group, which is equal to false. You need to flip it to true. That's like telling Kubernetes, hey buddy, let's keep all the kids in one playground. But this is completed on the master. We need to also do this similar activity for sudo space vim to change this from or flip this from systemd C group false to true in other worker nodes as well. So once it's completed, the same activity, we'll move on to disabling the swap. Why we're doing this is Kubernetes hates swap, hates it. Why? Because swap memory slows things down. Run the command is free space -m. And you should see the swap is 0. It's not enabled, so it's disabled. there's another command which you can use, like sudo swap off space -a as well. So it turns it off immediately. So currently we have checked it. So swap is off, so we don't need to run that command. I'm going to paste that command in the comments below. So if required for you, you can just go ahead and run that command, and that turns it off immediately. So let's move on to make it permanent in the F tab. So let me edit the, let me run the sudo space vim space /etcd /f tab. And I'm going to comment out the swap line because it's not present there. So for me, if the swap line is present, I would have commented out. So for me, the outcome is no swap, no complaints from any time for the kubeadmin later. So smooth sailing at the moment. We need to check this as well onto the other nodes as well. And the next step is to check the config file. So what are we checking here in the config file is IPv4. Okay, so we need to check for net.ipv4.ip_forward equal to 1. So let me scroll down or up. Yeah, there you go. I can see that we need to uncomment this line. Yes, Linux, you are allowed to forward packets. Be social, to be honestly. And once you uncomment this, save the file. Okay, once you change the systemctl.config file, we need to do that same thing on the worker nodes as well. Uncomment the line net.ipv4.ip_forward equal to 1. And need to do that same to the another worker node as well. And apply changes. Once you apply changes, it ensures traffic flows smoothly across pods and nodes. Without it, you would have Kubernetes with stage fright. Can't talk to anyone. And let's go on to the next topic, which will be enabling the BR net filter. Before that, what we have to do is, why we are doing this, it's a special need for the kernel module BR filter. Without it, Kubernetes networking plugins would cry. Let's go ahead and type in the command sudo space vim space /etcd /modules-load.d /k8.config file. So this is going to create a file, and then we're going to add a new line in that. So let's quickly check, moving to this folder, yeah, and create it. And just type in the command br_net filter. Once it's done, you're going to save the file. And the outcome is every boot with load the module. It's like teaching the Linux a new word permanently. We need to do the same activity in the other two nodes as well, in the worker node 1 and worker node 2. Let me copy it. So we need to reboot the servers. Why rebooting? All our tweaks live in memory until the reboot. Reboot makes them permanent. The outcome would be like servers come back fresh with containerd, no swap, bridging, and net filter ready. Let's move on to the next topic of adding the Kubernetes GPT keys. And let me head to the documentation, the Kubernetes official website, and follow step-by-step guide here in installing and configuring Kubernetes into our Linux node. And under this, you should see like download the public signing key for the Kubernetes package repositories, the same signing key it's used for all the repositories. So let me head back to the master node and clear and paste that command in here. So what it matters here is it's like trust won't install unsigned packages. This key verifies the Google repos. Once you type that command and hit enter, and let's move on to the similar one into the S1, that's the worker node, clear it, and then paste the command and hit enter. Once you see that, we need to do that into the worker node 2 as well. I think I missed pasting it. So let me go back and copy the command and come back into the worker node 2 and paste it and hit enter. So it will go back. So what I'm trying to say is it will follow like trust, security, stability, repeatability, and good hygiene. And the next step is adding the Kubernetes apt repository. If you scroll down a bit, you will see like add the appropriate Kubernetes apt repository if you want to use the Kubernetes version under this. And once you do that, because the source of truth tells apt where to pull the kubeadm, kubelet, and kubectl from. So let me paste it under the master node first and hit enter. And I need to do that for the worker node 1. Paste it and hit enter. And do that onto the worker node 2 as well. And hit enter. So this will be pinned vendor as well for the Google official repo from timely updates. And it will have some consistency matching documents tools. As I mentioned, like always follow the official documents. Let's update, refresh all the packages and metadata by typing this command sudo apt update. So why do you want to do this? Like you always want to have a refreshed index, and also dependency resolutions. And if there are any pre-flight checks, that will be, installed. If there's any cache warm, packages will install as well. So once it's completed on all the 3 nodes, master, worker 1, and worker 2, we need to move on to the next topic, which is like updating apt packages and install kubeadm, and kubelet. We're going to do this all in one go. And I'm going to edit this command, add this as kubeadm for that, and kubelet. I'm going to go into sequence. Either ways, why these 3 is kubeadm is the cluster bootstrapper. It's like init, join, upgrade. Kubectl is your magic wonder to talk to the cluster API. And kubelet is per node agent that runs pods and reports status. So we need to do this activity on all the nodes. So we are installing on master, worker 1, and worker 2. So there's another activity. Actually, what we could do is like we can create a golden template. Like out of master, once we have created master, we could have done that to the worker node 1 and worker node 2. This is the one which I'm talking about, like sudo cloud init clean. What exactly it does is like it's a fresh first boot, forces cloud init to rerun on the clone. And the second command is sudo rm space -rf space /var lib cloud instances. So it's a unique identifier. Clones shouldn't share the same instance ID. And the next one is to sudo truncate command. It's like you need node ID, differs per cloud, and also it goes through the DHCP sanity, cluster health, and audit clarity as well. The next command is sudo rm space -r var lib dbus machine ID / I missed that. So it avoids mismatches, don't leave any old dbus machine ID behind, and prevent race conditions. And the next one is system link dbus to etcd machine ID. So one ID to rule them all. and dbus always read the canonical ID. And the quick checks is optional but great on this one. So let's do a quick check by ls-l and also cat command to verify the system link is points to the etcd. Let's power off. Type in the command sudo space power off, and the template would safely s2, that is worker node 2, and we have created a template, and we have right click and create a template, and from the template we're going to create a virtual machine. So, and then we're going to create a clone virtual machine from that. So what we're going to do here next is we're going to right click on that created template and click on clone, and then we're going to give a ID as 103, and instead of linked we're going to do a full clone and give it a name as k8-s-3, and then click on create. Yep. And we need to refresh this, and you should be able to see the VM under that ID 103. There you go. So we have a newly created VM. So let's get started. Let's check all the information. Looks right to me with the process, BIOS, display, machine, and all other information. And let's move on to the next topic, which is options. Yeah, looks good. Start booting order takes 15 seconds. Delay. And yeah, and all the other options looks familiarly good to me. Let's move on to the next section. Let's SSH into the newly created VM. That's S3. We have the IP address. Let's move on to the MobaXterm and create a new session. Oh, sorry. Let me go back. Yeah, SSH, and paste the remote host IP address. Specify the username to good shoes. This is when you created this, and in the advanced SSH settings, leave everything default, and click OK. Terminal settings, network settings, and bootmark settings. Keep everything as default for now, and click OK, and accept, and they should be connected. Oh, it says like authentication method unavailable. So let's go ahead and edit advanced SSH settings. Let's add the private key which we created at the beginning of this one. So click OK, and this should connect us to connect as and good shoes. There you go. It's all connected to the S3. That's the worker node 3 we've connected, and it's because we have created a template, and all the other settings which we have created from the S2, that's the worker node 2, will be similar into the worker node 3. Now let's move on to the next bigger topic, is adding up the cluster. Now we need to create a controller node only, initialize the Kubernetes cluster. This one we're going to do it in the master node. Let's head back to the Kubernetes documentation, and where you see like this kubeadm init command, it's like you need to run this on the controller itself. So this is like boot the template origin master again into the SSH. Yeah. And you need to be a little careful here when you check. You need to check the command. It's like control plane endpoint, like stable address other nodes will use in here. And into the node name, it's a set as a clean, like predictable name for the controller. And you can also recheck it from the data center PVE. That's K8-M. And then the pod network CIDR, it is like 10.244.0.0. /16 because it will match us with the default networking, which we're going to create at later point, and the bootstrap control plane API server as well, and the control manager scheduler etcd. Let's go ahead and click on enter. Once you click on enter, you should see there is a required CPU limit is 2. Oh yeah, I remember. In the hardware, we have only set it to 1. So we're going to power this off before we make any changes into the master node and head back to the Proxmox PVE data center. And right click on the hardware, and we need to change this. Click on edit tab and change the cores from 1 to 2. And once it's done, we're going to click on OK. And you should be able to see that the core has been changed to 2 and socket is 1. And I'm going to power this off, like start now. And once the node is up, we're going to access it back into the cluster. That's the node, the master node. And we're going to use the same command back, like sudo space kubeadm space init. And check everything and click on enter. And this should go smooth in. You see at least followed up, and I'm able to see that the control plane is initialized successfully. And you make sure these commands, which you're seeing on the screen, you need to copy that into a text editor minutes, and then you need to run that onto the worker node 1 and the worker node 2. But either ways, what you could do is like you can also recreate it by kubeadmin token recreate one. I will share this command in my summary below. And once you copy it and paste it into the master node and export command as well, the kubeconfig and the admin.config file, and you should be able to use the kubectl command and then clear it. And I'm going to use to check the pods, kubectl get pods. Oh, error, loading the config file. Looks like there's a permission denied. I need to set up the permissions. So let's wait. Okay, so in here, let me try sudo space export and see. I don't think it's going to work because it requires non-sudo user. Let me still try it. Yeah, the command not found. So what we're going to do here is we're going to fix few things. We're going to fix the permissions, like taking control of the sudo as well. And it's because it's error loading because of the permission denied. We're going to do some other run some other commands, like this command is like ownership fixes, like ensure your user can read write the home.kubeconfig file without the root. And let's check. And if the kubectl is happy here, oh, what's permission denied still? I think it's not working as a non-root user. Let me change it to the root user. Let me change my password for the root. And from the root user, retype it the password. It's because normally Ubuntu root is locked by default. And let's use the switch user to, and then let's move on to, once after you switch it, let's grant the user the sudo permissions only to complete the kubectl one. And once you switch to the root, you're in the root, and type in the command sudo space usermod space -a capital G space sudo space the username, good choose. So we're going to have the least privilege by default for this user, good choose, and we're going to make this as a benefit to be done for it. And check the group is going to verify group membership for this user. And let me type in clear. Let me type the copy this command sudo and paste it into another worker node and also into another worker node as well. And because I've already done the sanity check by running the group space could choose, let me delete all of them and clear into another node as well, and clear. And let's check if the controller is working as default. Kubectl get pods. Oh yes, there you go. It's default namespace and kubectl get pod space -a. And the status is pending. So let's move on to the next topic. What we're going to do here is, because all the pods are in the pending state, we're going to install the CNI plugins, which is the networking Flannel, the controller. So let's move on to the official website, the flannel-io GitHub website, and walk through the README document and deploy it to the kubectl. Namespace, I've copied the command, pasted in the master node, and the namespace is created. And now I'm going to copy the command itself for applying the funnel, and copied and pasted back in. So why we're doing this is like the overlay networking matches our CIDR as well. So which we have created with 10.244.0.0/16 by default, and also daemon set model auto runs on the agent on every node to join. So once it's completed, which also unbox the core DNS, and it says all created. That's great. Now what we're going to do is we're going to check our pods are running. The status is running. There you go. You can see that the status is running for all the pods under the default namespace, on the all namespaces. It's like state change from pending to running. The final status look like pods are all running now. Now I'm confident, confirms that CNI is working before adding the worker nodes. So let's take a node snapshot of it. What do you say? Okay. So let's run the kubectl get nodes under the master node and see there is only one node has the status ready, roles as a control plane, and age and version, and the baseline of it. Let's move on to the worker node 1 and type in get nodes. It's because it's not added. So this is the next topic we're going to do, is like add the worker nodes to the master. How are we going to do it? We're going to run through one of the kubeadm join command. So as we have copied already in the text doc editor, the kubeadm join command. So let me clear it and paste that command here. Sudo space kubeadm space join, and followed by the control plane endpoint. That's 666443, and then the token. Yeah, and it says the node has joined the cluster successfully. This is what we require to do it on the next node as well with the kubeadm join command. And I see the node has joined cluster successfully. Great. So this means like there is a security handshake with the token plus CA for the nodes, and this is being registered to the master node as well. So what we're going to do next is we're going to check the kubectl get nodes on the worker node, but there's an error, but we could go back to the master node and check with the same command kubectl get nodes. Hey, successfully joined the controller, and the ready state is the status is ready, and each worker node has become ready. And the core service is stable, and we have the green light that the cluster is now truly multi-node and ready for app workloads. I've rechecked it again. Now, each worker node has joined to the master node. And what we're going to do next is we're going to do a small activity by deploying the Nginx into the cluster. Let's head back to the Kubernetes documentation page and create a deployment. This, like deploying a container to prove it works, let me copy the deployment YAML file from there and create a YAML file like mkdir space nginx deployment -test. And then I'm going to create the vim space deployment.yaml file. I'm going to do I for insert and then paste it the complete YAML file which I copied from the documentation. And once it's done, I'm going to save it with, and then I'm going to run the command kubectl space apply space -f space deployment.yaml file. And once the deployment is created, I'm going to check the deployments, kubectl get deployments. And I can see that 0 of 3 ready. Let me retype that command again. Kubectl get pods. I see ready state 1 by 1 and status is running. There you go, declarative flow, to be honestly. I'm able to see that running means your pipeline works end to end, or the pods run end to end. There's no require for the debugging at all. And let me check a few other information by running -o white. Now let's move on to the next topic, which is like expose this with the NodePort service. Okay, let me curl with 10.244.3.2. We have an output. Okay, it's an HTML output. And it has successfully installed. Let's create a service.yaml file within the same folder. And I'm going to head back to the Kubernetes official documentation page and search into service. And under the service, I'm going to copy or look for the service, kind service, and then under the NodePort, and I'm going to copy the whole section of this into my newly created service.yaml file, because I'm going to use the specified NodePort value from here. And for instance, I'm going to paste the complete file here, and I'm going to edit few sections. I'm going to change the name from this to Nginx-service, and then the type is NodePort. I'm going to remove this line and then edit. And I'm going to go down a little bit and change the target port to Nginx-HTTP. And it looks correct. I need to update that under the selector, as I've already done that as app Nginx, and save it. And I'm going to update this into the deployment.yaml file as well. Go back to, and under the ports, under the container port is 80, and the name is Nginx tilde. I think I need to remove that. Nginx-HTTP. That looks good. And rechecking everything. Let me rerun that. And let me run the command kubectl get pods -o white. And then let me check the kubectl get deployments -o white. There's one deployment running. That's good. Let me check get services white. There's a service running. Get nodes -o white. Yeah, I'm going to tap the IP address from the Proxmox VM and then paste it into the browser. There you go, 192.168.0.14. That's the one from the node, and it matches with the node master node. And we have successfully created the service and the deployment. This video helpful. Don't forget to like, share, and subscribe to Good Shoes. Stay tuned for more tech tips and tutorials. See you in the next one.